Okay, so what we can see here is the x-axis is the frequency, so lower frequency events are happening here, higher frequency events are happening here. What we see here is that there's a peak in the periodogram that falls on some sort of frequency of 0.8 throughout my data set. I don't know what that is. I need to divide that by the time series length. So what I can see here when I do that is I have a peak that is annual, which is not surprising because we were expecting that. Every summer I'm going to have some warm temperatures. Every winter I'm going to have cooler temperatures. So I have a really strong annual signal, okay? And that is the strongest temporal variation in the Pacific, the annual cycle of SST. But there are other harmonics, what we call other waves going through the data. We see little peaks over here. We see a little peak over there, which is usually when we have a really high peak, there are what we call harmonics of that, which are a little bit to do with noise. But what we can see here are real peaks. One is happening every 1 divided by 36. And in our case, this is 1 in 12 months. Remember, our time series was monthly. This is 1 divided by 36 months, 1 divided by 48 months. We're having events that happen less frequently. If I just zoom into this section here, what I can see is that there's a peak that's happening every 3 years, 3.5 years, 5 years. What we're seeing here is the ENSO cycle. Okay, so we have a cycle of El Nino repeating at this frequency, okay, which ranges between 3 and 5 years. So I can use the time series object to create a periodogram that has, instead of frequency, the time in units, in my time units. So here it's annum, and we're going to do that in the computer lab. But 1 is a peak in annual, repeating once a year. So what this means here, so 0.2 times a year, which means every 5 years. Okay? So instead of having the frequency looking like that in the periodogram, I can turn it into, so if here my series was this one, in this case my series was the TS object. Okay, we're going to practice this in the computer lab. I'm just showing you that you can, I'm trying to get to all of you using all sorts of angles, but having either the periodogram frequencies or the frequencies described in that unit of time that you've defined, say annum. So 1 time a year, less than 1 time a year, so like 1 time every many years, and anything that would happen here would be 5 times a year. Okay, so we don't really have anything happening in the time series that is higher frequency than annual. So what we can see here are those annual variations in temperature. So we have peaks that repeat predictably every summer, and we have troughs that repeat every winter. Now, I'm just going to touch on, so that was it for understanding the spectra. The spectral density. So we will cover that more in the computer labs and in the tutorial. But we have here a few things we can do. So we have this time series, and we've identified the stable components of it, and we can create predictions into the future. We use these things, for example, using the ARIMA model. There are other ways of doing this. This is beyond the scope of our unit, but just so you know, once you have these components of the time series decomposed, you can use it to make predictions. And the other one we were briefly talking about is that intervention analysis. So I have a time series that has a certain trend, and it has some sort of point where there's a counterfactual, which is what I thought, how I would have continued this trend. But here's me drawing on a piece of paper, you know, and I'm looking at the computer, and then I look away, and like this is what my hand does. something happened at this point to cause my time series to deviate from the counterfactual, and this is called intervention analysis, working out where this point is in my time series and what it is that changed between before, statistically changed before and after the time series. Thank you.